Hi YouTubers, welcome to a video on undervolting and power management on a 13700K on ASUS Strix-E Z790. So this is the latest generation. And in this video we're going to do a few things. First of all, we're going to ask the question, why do this in the first place? Show how to do this using the BIOS as opposed to, let's say, Intel's XTU software application of doing the same thing. Show some thermal results in Cinebench R23 and even some gaming thermals and FPS benchmark as well. So what is the issue? Well, if you look on some of the forums on the net, you'll see that people are reaching this 100 degrees Celsius and throttling starts to occur, and you see a lot of red numbers if you're using thermal monitoring programs. And people are asking the question, is this normal? And my thoughts on this are, well, kind of yes. If your solution, cooling solution is not the best, you can easily reach this temperature. And even if it is good, you can still reach these temperatures. So it's a conundrum. And why is this even occurring? Well, with the 12th and 13th series CPUs, performance has been prioritized over power and temperatures. That's what Intel wanted to do, resulting in the CPUs running hot, and that's what people are finding, and requiring good cooling solutions. Like a minimum, folks are generally saying is to have a 360 cooler with nice fans. I'm going to say you don't need to do that. You can use a good cooler, but not necessarily a 360 cooler, and particularly if you run some of these tweaks I'm going to suggest. And the reason this is occurring is because more power and voltage is being applied by default to the CPU for boost clocks. And I'm going to show you exactly what I mean here. So people have suggested, well, undervolting is one way to lower the voltage requirement at the CPU to therefore run cooler and maybe not lose too much performance either. And that's, yes, I'm going to say that's true, and I'll show that. I also am going to suggest that you do another thing, and that is, as this person found out, is look at the CPU power management in the BIOS and limit the amount of watts the CPU will get from the motherboard as a way of reducing the thermals on this CPU with little loss in performance in the end. Okay, so the other question to answer is, what are the benefits of doing this? And of course, improve thermals, and that's really the longevity of the CPU. Lower fan speeds, and for me this is a big factor. Less noise for me. I don't use a gaming headset. I have a surround sound system, so I don't want to hear my PC at all. Less power usage over time, that's some cost savings for sure, especially if you use your CPU for workload applications and are generally pushing it higher than gaming. And really there's little or no loss in performance, and I'm going to show that in some Cinebench and gaming results. And really, at the end of the day, there's no need for default voltages used for the boost clocks that Intel has set by default. So stay tuned. I'm going to flip over to the BIOS and we'll show you how those settings for power management and voltage undervolting is done. Okay, here we are in the BIOS, version 0703. First thing I want to show you is the Q-fan control with my CPU fans more or less maxing out around 75%. These are RPM 2000 Noctua fans, so this is going to max out about 1450 in applications that are requiring it. Okay, so that's Q-fan. So we need to go to the advanced mode. Here's the advanced mode, and to make this voltage tweak, we need to go to AI tweaker in the advanced mode. And yes, I have XMP1. Scroll down. Oh, first thing to note, I've disabled, this is the multi-core enhancement. I've disabled enforce all limits, so it doesn't push all cores to the same performance level. It just lets the ones go there that can or should. And then I want to go down to a couple things. First of all, internal CPU power management. This is another way of limiting the voltage to the core and keeping thermals down. I've set a maximum CPU core temperature at 90. This is the way I just like to start throttling at 90 degrees if the core gets that hot. This is normally set to auto, and it would push up to 100 where it would normally start throttling, with 110 being the limit, but 90 is what I like to see, so that's what I set. Now the other thing you would like to do for power management, because Intel lets these things run demand as many watts as they want. This is usually set on auto and also set on auto, and this will run past 125 and then therefore reach a demand more voltage and then I'll obviously get hotter. So what I think I would recommend doing is put the default long duration power limit. So this is what it will use most of the time at 125, and that's the Intel specification. This short duration power limit is 253, but it's when you put this in auto, you'll see a bracket down here and it'll show up to 4099 or something like that. It's just open-ended. Both of these can be open-ended, and I would suggest keep this thing cool even without voltage tweakings. Save this as 125 and 253, and it looks like you can't do anything. It's like a non-clickable, there's no arrow down. You just need to click the box and type it in and it will work. So that's the power limit. If we go down to offset mode design, you'll see that under global core SVID voltage, I have it on adaptive mode. So you want adaptive mode because that allows enough voltage to reach the core when boost kicks in. You can set things for offset mode, but you should know what your minimum voltage is or desired voltage is for running the offset. Adaptive will always allow you to boot and run programs. It will grab the voltage it needs and then apply this offset down here. So make sure the offset mode is negative if you're undervolting. Leave this on auto. That's my suggestion. You could put a specified voltage here, but I would leave it on auto. And here's where I have it at 0.1. So if we are to reset this thing to test it with default, I'm going to go auto here, and then everything is set back to auto. And we'll just save and exit so that we get an idea of what the system will run at without any undervolting. Okay, let's look at some Cinebench results, more or less 25.5 in the points. And if we move over to the V cores, we're looking at about 1.31 to 1.356 on the max, and then just a little over 1, closer to 1.1 on the average voltage. Temperatures peaking around 87 to 90 sort of thing in the red. So about what, 4 or 5 cores, 5 cores, 2, 4, 6 cores actually hitting the red. And averages in the mid 60s to mid 60s, upper 60s sort of thing. Package is hitting around 90 degrees, which is the thermal threshold set. And here's the important thing, the power. Okay, we're at a little bit over the 125 default, or not default, but if you set it at 125. This is open-ended right now, so it's 129, not much over 125. Here we hit 228 with the default or the setting you could put in there at 253. So still under that. And our fans pretty much the CPU maxing out at according to the fan curve. Okay, if we move on to the undervolting power management scenario, we have a little bit better score. Take this 3% performance increase with a grain of salt. It really varies from run to run, so let's just call it the same. Maximum voltages, of course, are lower, but less than 0.1 volt, but that's okay. We're going to have some fluctuation with adaptive. Average is about the same, maybe a little lower. Average temperatures are just a little lower as well than the automatic mode. Maybe one less core hitting the max, and a little bit lower on the CPU package core max temperature. Of course, the watts used is at 125 set already purpose, and we hit 203. So a little less max voltage used, peak voltages used at times. Fan curves are the same because it's running at according to the fan curve. So that's Cinebench. If we move on to some gaming and we look at Far Cry 6 benchmark, this is results for the automatic mode, auto mode, and I saw peak temperatures around 58 and maybe a little bit lower at times, but mostly around that 58. And if we move to the undervolted scenario, oh sorry, I should say that most of the time, however, that's the peak voltage of 58, but we're in the 50 to 60 range a good part of the time. So really not that hot or worrying in any case. And FPS 103, okay, no big deal. With the undervolting scenario, we have peak at 53, but most of the time in the 40 to 50 range, and that's really nice to see for such a game. It's not super CPU intensive, but it is, I guess, one of the more CPU demanding games that you can play in the X12 at least, and they're at the same FPS. Okay, let's get to some summary and conclusions. So really, if you're not happy with your thermal profile or throttling on the CPU with a 12 or 13 series Intel CPU, or really, quite honestly, any CPU, check your thermal paste. That's the first thing to do, and cooler operation. Just make sure those are working as they should. And then you can try these voltage and PL1, PL2 power tweaks and see if that benefits you. I would suggest using the above approaches for best results. Bit of a fail-safe, I suppose. I've tried both of them separately, and I find together work the best. I like to use the adaptive voltage all the time, and I suggest you do, just to make sure you have safe boots and applications, and maybe try 0.05 volts or less at a time as you're lowering the voltage. The best benefit, I think, is not with the Cin23, the demanding benchmarks. They're always going to push the CPUs high no matter what. I think one of the best benefits of doing this is actually with low CPU demand applications, such as gaming, or lower CPU demand applications. Here we saw 10 degrees differences in gaming sort of thing, and in other games I see it in the 40s. So DX11 games, for example, and other DX12 games. And there's little or no loss to the FPS. So you can't go wrong, really. I think it's useful to do this if you're concerned about CPU temperatures in games. The FPS, I'm at 4K, so again, not a lot of difference between the two scenarios. So also note that. The bottom line for me is less noise and less power. That's what I want to achieve. I don't like to hear my fans, and that was my purpose in investigating this, really to balance noise and efficiency and performance. So I think for me, I've done that. And with that, I thank you as always for watching, and hope you enjoyed a little bit of this learning. I certainly did. Here's a snapshot at 42 degrees, for example, from Plague Tale. Take care. See you again.